this problem here. So this problem is asking us to determine the capacitor voltage. We're not going to worry. I don't know. Yeah, power. Yeah, voltage, power, and stored energy at times equal to 20 milliseconds. Okay. So taking a look at this circuit, let's see what we have here. So looking at our switch, this switch indicates that at time before we flew the circuit, this was closed. But as time went to infinity, it'll be open. Okay. So if this is open, that means that the current that leaves from this source comes up through here, hits this point, sees it can't go down this branch because it's open, and sends all of its current through here, okay, through the capacitance. So now we know the current, and it's going to be constant because it's a constant source here. There's no flux, or there's no fluctuation. It's not AC, it's a DC. Okay. So looking at our formula sheet that we had, it's actually attached to it's a 5th page, the sheet I'm sending out. We can see that to find the voltage, we'll use this V of C equation. So V of C will be equal to 1 over C, T1, T2, I of T squared dt plus V T1. Okay. But we know initially, because it was closed, I'll do therefore V of C at time 1 is equal to 0 because there was no current flowing through it. You can't store anything. So we know that will go to 0. Okay. So now it's just going plug in all of our numbers here. So 1 over 10 microfarads, 0 to 20 milliseconds. Our current is 2 milliamps. I'll square that. Wait, actually, take a look. It's not squared. Wrong equation. Wrong equation. So just make sure you're using the right equation because you can get messed up on that. That's for the RMS, actually. So now dt and plus 0. So if we pull all of this out here, we'll get 2 milliamps over 10 microfarads. Then we'll integrate and we'll get T. We'll go from 20 milliseconds, starting initially from 0 milliseconds. Okay. So V of C, 20 milliseconds. Okay. This will be 2 milliamps for 10 microfarads, 20 milliseconds minus 0 milliseconds. And when we do that math, remember we want to work with base units. So yeah, just remember micro is equal to times 10 to the negative 6. Okay. When we do that, we'll get 4 volts for V of C at 20 milliseconds. All right. Now let's look at the power equation. So power is going to be V of T, I of T. So at 20 milliseconds, the voltage we said was 4 volts. We know the current is going to be 2 milliamps. So therefore, we will get 8 milliwatts for the amount of power we're going to have at 20 milliseconds. All right. Finally, let's take a look at the energy. So energy is going to be WC of T is 1/2 CV squared. Half capacitance we said was 10 microfarads. The voltage is going to be 4 volts. Square that value and we will get we will get 80 microjoules, and that is the amount of energy that we have at 20 milliseconds. All right, so it's just using the equations and just plugging them in. But this bit up here, that's important to know with switches. All right, well, I will see you in the next video. Thank you.